Good morning, everyone. We seven students, all your friends, classmates, past. Acha, can you see my screen? Is it visible and am I audible clearly? Okay. Okay. So I actually missed one part here to include one part before your filtration. Mm, Okay, let me first tell you something about that part which I had missed to put it here. Later I can include it to you. I can send it to you. Okay. Later I will click picture and I will send it to you. Okay. But now I forgot. So let me tell you what which part I missed out. Okay. So the topic is your it's your the constituents of a coagulation sedimentation plant. Okay, the coagulation. You just listen. Okay, there is no PDF, but I will just tell you something about this one. It's your the constituents of a coagulation sedimentation tank. So that means like we have done in last class about coagulation. Okay, sedimentation aided with coagulation. So where that thing of mixing of coagulants and all it is carried out. So obviously it will be carried out in a plant, isn't it? In a certain plant, and that is known as your clariflocculator. Okay, uh, the term is known as your clariflocculator, also known as your coagulation sedimentation plant. Okay, so basically there are if constituents are asked, so basically there are four types of constituents. That is your number one is your feeding device. Number two is your okay. You can do one thing. You write down the topic. Okay, you write down the topic. Wait, I will. You can see my screen. Can you see the Word MS Word screen? Okay. So just you can write it down if you later forget. So I will provide you, but then also it's better to write it down. Okay. I will write a little bit and then I will explain. Okay. Constituents of a coagulation sedimentation plant. Okay. So basically, what is a coagulation sedimentation plant is known as? It is known as your in bracket. I am writing it down. Clariflocculator. Okay, it is known as your clariflocculator, and this whole process it is carried out in a clariflocculator, and it has a certain steps. Okay, so number one is your the device name is feeding device. Okay, number two is your mixing device. Number three is your mixing device, or you can say mixing basin. Okay, and number three is your flocculation tank or flocculator, and last number four is your settling or sedimentation tank. Okay, so these four are the you can say the devices. So quickly let me show you, not show you, first I will tell you. Okay, that what is done here. Okay, the process is same like you have known that what is done in coagulation process. Okay, so this mixing device is what in the plant. Okay, in a Clariflocculator, in a mixing device, what happens? You can it is of two types. Okay, this feeding device is of two types. Number one is your it is said as your wet feeding device. Okay, and another one is your dry feeding device. Okay, it's of two types: wet and dry feeding devices. Clear? So water, wet and dry feeding devices is that the coagulants. Okay, it is normally of you can put the coagulants in a dry powdered form. Okay, and also in a solution form in the water. Okay, so if you put the coagulant in a powdered form, so it is known as your dry feeding device. And if you pour the this coagulant in a solution form, okay, you mix it with water and you make it a solution, and then you pour it in the feeding device, then that is known as your wet feeding device. Okay, so after you have put the coagulants either in your powdered form or in your solution form, so your feeding device, the working principle of feeding device is finished. Okay, so the water, it is after mixing. So after pouring the coagulants, it is sent to the next part of your device, that is your mixing device. Okay, so what is done in mixing device? You have already learned that it is here in your mixing device or a mixing basin. A very thorough mixing is given here. Okay, and this mixing, it is it is done. There is also a two types of mixing basins. Okay, normally, generally, your mixing basins are more preferably used. Okay, and there are two types of mixing basins. Number one is your mixing basins with baffle walls. Okay, so number one, you can say two types. Okay, mixing basins with baffle walls. Okay, and number two is your mixing basins equipped with mechanical devices. Clear? Now I would like to show you how a mixing baffle looks like. Okay, so let me just open my Google. Okay, this one. This one, you see this diagram, you can see. So this is a mixing basin. It is a rectangular tank. Okay, it is a rectangular tank, and here baffle walls are provided. Okay, these are walls, you can see. These all are walls in opposite directions. Okay, so what happens when the after you have poured a coagulant in your tank, the next process is that that water, it is sent to a mixing basin with baffle walls. So the water is passed through it, and what happens, due to the flow velocity, the water, it strikes this baffle walls. Okay, it will strike here, then again it will strike here, then it will strike here, like that. It is continuously striking the baffle walls. And what happens if when it is the striking the baffle walls, is that the water, it is completely and it is thoroughly mixed properly. Okay, a very very nice mixing is given in your mixing basin. Okay, so why, as we have already learned before in coagulation, that when the mixing is done, a very nice and thorough mixing is done, what happens, a flock is produced. Yes, a gelatinous precipitate is produced which will attract the other fine particles, isn't it? So when in this mixing basin, the water, it is given a thorough mix, okay, thorough mix, and then the water, the work of the mixing basin, it is completed, okay. Next, the water, it will go to a flocculation tank or a flocculator, okay. So what is done in a flocculation tank is that after the water, it is given a thorough mix, here in a flocculation tank, a gentle stirring is given, okay. A gentle stirring is given, so that, after a thorough mixing, it is given now a gentle stirring, so that a nice, gelatinous precipitate is formed, okay. So in flocculation tank, your gelatinous precipitate, or you can say flock, it is produced, okay. So after, in the flocculation tank, as soon as the flock is produced, so in flocculation, there are, you can say, some paddle type things, okay. Some paddle, you have seen paddles in like round, circle thing, okay. There are paddles, so it is slowly, it is moving, okay, in a circular way. So when the paddles are moving, the water, it is given a, a very, you can say, a very slow, relative slow, it is giving a stirring, and as for that, what happens, a precipitate, it is formed, okay. So after the precipitate, or the flock is formed, it is that thing, it is sent to the settling or sedimentation tank. And in sedimentation tank, what is done, it is kept in a still position for, some detention time. And the that flock, it, since it is now a heavy, it becomes heavy, so it settles down, and the settling particle, it can be easily removed from your sedimentation tank, okay. So this whole, it is a procedure of how a coagulation sedimentation plant works, okay. So these four are the constituents of your Clariflocculator. Clear? Okay. So your coagulation, aided with, sorry, sedimentation aided with coagulation is finished, okay. So after, wait, let me open my PDF. Okay. So now, your next step will come, that is your filtration, okay. So we have already learned that in this plain sedimentation, the suspended particles, those are removed, the fine suspended particles. And again, when the fine suspended, those fine suspended particles whose specific gravity is not greater than 1, so those particles will obviously keep floating in the water, and so for those particles, we have to add some coagulants, so that we can make them heavy and they settle down, okay. So but that is not the end of your treatment process, okay. And after you add coagulants to the water, there are still some, you can say, some fine, very very fine suspended particles that keeps on floating in the water again, okay. Because each and every particle, you can't say that it will be, removed by coagulation process. Yes, you can say 60%, 70% of the by, so very fine suspended impurities can be removed. But then also, that is not the end of your treatment process. So after that, we need to do filtration, okay. Because your when, some of the particles that gets, it becomes a flock and it settles down. But then also, in that water, some very 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 fine, impurities are still present, and also you can say bacteria are also present in water, okay. Pathogenic bacteria are also present in water. So for removing, okay, for removing the bacteria, and also the very very fine suspended, very fine suspended impurities, we need to do some filtration, okay. We have to do filtration. And you see here, and what are the, everyone knows, I guess, what are the materials that a filtration use is what? Sand, gravel, isn't it? And in your home also, you have in your water treatment, sorry, in your water tank, or you have seen that generally everyone uses a sand and your gravel as your filter media, isn't it? So here you see here what definitions you can write. You I'm reading out from here, okay? See, screening and sedimentation removes a large percentage of the suspended solids and organic matter present in raw supplies. The percentage of removal of the fine colloidal matter increases when coagulants are also used before sedimentation. Yes, but however, the resultant water, it will not be free of impurities and may contain some very fine suspended particles and bacteria present in heat. Okay, so to remove or to reduce the remaining impurities still further and to produce potable and palatable water, the water is filtered through the beds of fine granular materials such as sands, etc. Okay, so here these definitions you can write. The process, right? The process of passing the water through the beds of such granular materials means sands and gravels, okay, called filters, is known as filtration. Filtration may help in removing color, odor, turbidity, and some pathogenic bacteria from the water. Okay. So I hope filtration is clear to you, and also this word is very familiar to you. So I guess you people know about filtration, right? So 10% knowledge everyone has about filtration. Yes. So let's see uh, what else is there about filtration. Okay, so there is a theories of filtration. Okay, there are four theories of filtration. So let me draw one thing. Okay, so you have to filter media, that is your sand and gravel. So in the theories of filtration, number one is your mechanical straining. So what is mechanical straining? Let you see here, the suspended particles present in water and which are of bigger size than the size of the voids in the sand layers of the filter cannot pass through these voids and get arrested in them. The resulting water will therefore be free from them. Okay, most of the particles are removed in the upper sand layers, the arrested particles including the coagulant flocks. Okay, so you see what happens in mechanical straining is that the impurities, okay, the impurities which you are the water you are providing, okay, so those impurities they have the size of the impurities, those are greater than that of the sand size particle. Okay, the size of the impurities in the water is greater than that of the sand size. Okay, so what will happen, since the size is greater, so those impurities, it will stuck in the upper layer of the sand. Yes, it will get stuck since the size of the impurities is greater. So obviously the impurities will stuck at the above the sand layer, and it will form a mat. Okay, it will form something, a mat on the top of the sand bed. Okay, so that mat, okay, that mat layer, it can be removed by mechanical straining. Okay, so in your mechanical straining, it is said that the impurities whose size is greater than that of the sand size, so those impurities, it cannot pass through the sand voids. Okay, it cannot pass through the sand, and those, they are removed in the upper sand layers, okay, by mechanical straining. And so your next is your flocculation and sedimentation. Okay, so what happens to those impurities whose sizes are lesser than that of the sand? Okay, so what is done here, you see, it has been found that the filters are able to remove even particles of size smaller than the size of the voids present in the filter. This fact may be explained by assuming that the void spaces act like tiny coagulation sedimentation tanks. The colloidal matter arrested in these voids is a gelatinous mass and therefore attract other finer particles. Okay, so you see the impurities, okay, which whose size are less than that of the sand size, obviously it will get through the sand bed. Okay, these will enter the sand bed. Okay, here, so as soon as it enters the sand bed, since the colloidal particles, okay, these are the impurities are colloidal particles, obviously. So the colloidal particles, are gelatinous type of things. Okay, gelatinous means those are like, greasy things. So those when it enters the sand bed, what it does, it attracts the, since it is a gelatinous flock, so it attracts the other particles. Okay, it attracts the other fine particles to it, and what happens, finally it will settle down, and finally we will get your clean water. Okay, so next is your biological metabolism. So what is a biological metabolism? You see, in your water bed, okay, in your water bed, some bacteria are present. Okay, so bacteria are present, and those bacteria, they need some algae or planktons, all these things that are present in water for their survival. Yes, so when those water which you are giving, okay, the water that is coming, impurity water, dirty water that is coming in your filter media, so those water, it might, consist of some algae, plankton, all those things. So these bacteria in the water bed, what they do is that they eat those. Okay, they eat those planktons or bacteria. Okay, for as their food for their survival. Okay, so as soon as they they eat that food, so the water, it becomes clear, and that is known, it is by biological metabolism, it is said. Okay, so these organisms, these bacteria or organisms, you can say, they utilize, such organic impurities such as your plankton or algae. Okay, and they convert them, okay, into what, into harmless compounds, because they eat them, and it is by the process of what, biological metabolism. Clear? And last one is your electrolytic changes. Okay, it will be charges, not changes. It will be charges. It will be R. Okay, electrolytic charges. So what happens in electrolytic charges is that the sand top layer of the sand bed and the water that is coming both have opposite charges. Okay, both the sand bed and the water that you are providing both have opposite charges, and so when it comes in contact with each other, what happens, they destabilize. Okay, it neutralize the charges. And when neutralization happens, so you will they change the character of the water, and it makes the water purer. Okay, uh, again, so you see, after you are putting the water, so after some time, okay, the electrical charges that is present on the sand bed, okay, or the sand grains, you can say, so it gets exhausted. Okay, uh, it gets exhausted, and what happens, to again to restore them, we have to put we have to put or new sand, or you can just clean the filter. Okay, so this is all about your theory of filtration. Okay, so next is about your filter materials. As everyone knows about filter materials, but then also uh, we will just read it out. Okay, so we have sand. Okay, sand is the most important material. So sand, you see, the fine filter sand should generally be obtained from rocks like quartzite and should contain the following properties. Okay, so number one, it should be free from dirt and other impurities. Okay, it should be uniform in nature and size. It should be hard and resistant, and it should be such as not to lose more than 5% of its weight after being placed in hydrochloric acid for 24 hours. So these four are the properties of the sand, of what kind of sand you should use in a filter media. Okay, so number one, you can see here, it should be free from dirt, then it should be uniform in nature and size, it should be hard and resistant, and then it should, most importantly, it should not, if you put the sand in hydrochloric acid for 24 hours, then it should not lose more than 5% of its weight. Okay, so these are the properties. So let's see the next property of filter media, that is your gravel. Okay, it's gravel. Well, the gravel which may be used below the sand should be hard. Okay, it should be hard, durable, free from impurities, properly rounded, and should have a density of about 600 kg per meter cube. Okay, gravel of different sizes are usually placed in 3-4 layers, each of 15 to 20 centimeter depth, with the coarsest size 20 to 60 mm placed in the bottommost and the finest size 3 to 6 mm in the topmost layer. Okay, so gravel, they are obviously, it is of different sizes. So the coarsest size, that is 20 to 60 mm, are put in the bottom layer. Okay, and the finest size, that is to 3 to 6 mm, they are put in the topmost layer. Okay, so these are the properties. You can write it down in points in your copy. Okay, next is your uh, types of filters and your classification. Okay, so for filters, obviously, for filtration process we need filters. Okay, but there are different types of filters. Okay, there are different types of filters. We will see here. You see this chart. Okay, then you can remember it easily. So for filtration, basically, if you classify filters according to their gravity and pressure, so according to gravity and pressure, it is of two types. Number one is your gravity filter, and number two is your pressure filter. Okay, so gravity filters, normally you have to maintain the water head. Okay, the water head from which you are pouring the water to the sand medium, so that is your gravity filters. And pressure filters in a confined tank, or in a confined tank, when the filtration is done, it is known as your pressure filters. Okay, so again, gravity filters, you have two types. One is your slow sand filter, and number two is your rapid sand filter. But again, if the according to the rate of filtration, if you need to classify them, then the filters can be on the basis of rate of filtration. It can be classified as slow sand filter and rapid sand filter. Again, rapid sand filters can be divided into rapid gravity filters and pressure filters. Okay, so these are the basically, if someone asks you what are the types of filters that you use, you can say slow sand filters, rapid sand filters, and also you can mention about your pressure filters. Okay, pressure and gravity filters also you can mention, but you need to see about on the basis of what they are asking. If they are asking about the basis of filtration, rate of their filtration, then you will just say that it is slow sand and rapid sand filters. Okay. So in the next class, we will discuss about in details about your slow sand and rapid sand filters, and we will also see some differences between them. Okay. So we will end the class today here. Let me take your attendance. Roll number 69.
Yes, ma'am. Yes, ma'am.
Okay, 51.
Present, ma'am. 51.
Okay, 52, 53, 54, 55, 56, 57, 58, 59.
Present, ma'am. 59 present.
Okay, 60.
Present, ma'am.
Okay, 61.
Present, ma'am.
Okay, 62.
61 present, ma'am.
Okay, 61 present. 62, Rupashri. She was present. That time I saw where she went. Okay, giving her present. 63.
63.
Okay, 64, 65, 66.
Yes, ma'am. 66.
Okay, 67.
Present, ma'am.
Okay, okay, 68. Motiul. 70.
Present, ma'am.
Okay, 71.
Present.
Okay, 72. Kilitoli. She is present. 73. Okay, 74.
Present, ma'am.
Okay, 75.
Present, ma'am. 75.
Okay, 76.
Present, ma'am.
Okay, 77. Tensor. 78.
Yes, ma'am.
Okay, 79, 80, 81. Who said
Present,
80?
ma'am. 80.
Present. Okay, okay. 81, 82,
81.
81 present. Okay.
Present,
82,
ma'am.
82 present.
Present, ma'am.
Okay, 83.
Yes, ma'am.
Okay,
Present, ma'am.
84.
83.
Okay, 83 present. Give it. 84,
Present, ma'am.
84
Present, ma'am.
present. Okay, 85.
Yes, ma'am. Present.
Okay, 86. Likha. 86. 87.
Yes, ma'am.
Okay, 88. 88 present. Okay, 89. 90.
Present, ma'am. 90.
Okay, 91.
91. Present, ma'am.
Okay, 92.
Present, ma'am.
Okay, 93.
Yes, ma'am.
Okay, 94. 94. Not present. Okay, 95. Okay, 94 present. Okay, 95.
Yes, ma'am.
Okay, 96. 96. 97. Mika. 97. 98.
Present,
98.
ma'am.
98.
98. Present.
Okay, 99.
Yes, ma'am.
Okay,
Yes, ma'am.
100.
99.
Okay, 100. 100. 101. 102.
Present, ma'am.
Okay, 103.
Present, ma'am.
Okay, 104.
Yes, ma'am.
105.
Yes, ma'am.
106. 107.
Yes, ma'am.
Okay, 108.
62 present, ma'am. Ma'am.
Rupashri, I have given you present.
Okay, ma'am.
Okay. 108.